So here again in C, we're going to plug in our 9 to start. So we end up with 9 squared minus 81, which is 0. Square root of 9 minus 3, which is 0 as well. So we end up with 0 over 0. That is our condition for L'Hopital's. So I'm going to apply L'Hopital's. And we end up with the limit of x approaches 9 from the positive side of 2x in the numerator. In the denominator, we end up with 1 over 2 root x. Okay, we're going to simplify that expression. So we end up with limit as x approaches 9. And this becomes 4x to the power 3 over 2. Okay, so because the square root joins the x in the numerator, we end up with power 1 and power 1/2. We end up with power 3 over 2. So now we're going to evaluate this. So we're going to we end up with 4 times. Well, this is power 3 root 2, so we'll do the root first on 9. So it becomes square root of 9 to the power 3. So we end up with 27. So if we evaluate this, we end up with 108. So the limit as this approaches 9 from the positive side is going to approach a y value of 108. In this next example here, if I plug in, I'm going to end up with tan of pi over 2, which is infinity. So I end up with infinity, and then secant of pi over 2 is infinity as well, so we end up with infinity over infinity. So this is a bit of a problem because we need a ratio to be able to apply L'Hopital's, but this is an indeterminate form. So what we want to do is rearrange this expression. So we end up with x to the power over 2 from the positive side. And we want to put this into a ratio form, a square root form. A ratio form, so a fraction form. So putting this into fraction, I end up with the common denominator of cos. So I end up with sine x minus 1. So this is going to be sine over cos, which is tan. And then 1 over cos, which is our secant. So we end up with this. So now we're going to test this out. We plug this in. We're going to end up with the square root of 1 minus 1, which is 0. And the square root of the cosine of pi over 2 is 0 as well. So there's our 0 over 0. Now I'm going to use limit properties, and I'm going to do the limit in this way, because I know that applying limit rules, I can take the limit of the inside function and then square root it after. So there's my sine x minus 1 over cos. So I'm going to do the limit of that expression first, and then I'll apply the square root after the fact. I have my condition for L'Hopital's, so I'm going to apply my L'Hopital's here. Keep my square root on the outside here. And I end up with the limit as x approaches pi over 2. From the positive side, I end up with cosine of x over negative sine of x. So the limit of the cosine is going to be equal to 0 in the numerator and 1 in the denominator, so we end up with this. We end up with the square root of the numerator equaling 0, the denominator equaling negative 1, so the limit works out to be 0.